Hello. So for we were uh, understanding how we can fetch data from different sources, either web, either personal computer, either on um, any database, and also we learned about how to uh, load a different uh, data, different format of data. For example, if data is in JSON and if data is in text or um, any database or in CSV or TSV and all those steps. And also we learned about how to do the scraping or getting data from websites through help of Beautiful Soup. Now we are going to understand um, after getting data, what does data says, right? And we have to do some exploration around those data. And also we need to check is that data is good for us to take it further for any processing, or do we need to do some cleaning and all those steps. So in general, before we take it data further down the line for our business use case implementation, um, we should be asking uh, at high level these 7 questions. How big is that data? How does the data looks like? And what is the data types of columns? What are the are there any missing values? How does uh, data looks like mathematically? Are there duplicate values and how to remove that duplicate values? And how is the correlation between columns? So these 7 things will give you the holistic view or understanding about the data. So for that, as a standard process, we have to include import this library pandas and numpy for doing all these operations. And here we are referring training data, right? So let me show you how this train data looks like. So this data set, let's understand about this data set. This data set is Titanic data sets, which has passenger ID, survived, and class, and name of the passengers, sex of the passengers, age, and does that passenger has sibling or barge, and ticket number, fare, and cabin number, and embarked. Um Embarked is the station where passenger got onboarded. So in embark, we are having S, C, and Q. S means Southampton, that is in England, uh, and C means Chebag, which is in France, and Q is Queenstown, which is in Ireland. So these are the yeah types in the embarked, and this is how this data looks like, right? So uh, we need to get answer about how big is the data. So for that, if we will extract df.save, it will tell us how many rows and how many columns do we have in this database. So we have 891 rows and 12 columns, right? And the second question, how does data looks like? So just to have a gist of database data sets to visualize that, we should be calling it out df.sample 5. So it will take a random 5 rows and it will show. So for example, we are having passenger ID survived and P class, name, sex, age, and all those details. So this is giving us um, the simple view of data. Third question we should be asking, and how we will be getting that answer is what is the data types of the columns we should be understanding. So df.info will provide all the columns and its data types. Here you can see passenger ID, integer 64, and all others, right? So these understanding of data types is very important. Means by looking into the data and exploring its data type, you should be able to understand that this is not uh, quite big data set, even though, but it's a type will make impact if data set is quite huge and you are uh, uh, using a higher data types. So for example, uh, this column, right, P class. So we are having integer 62. We don't need integer 64. It might be integer 60, 32 will be helpful or lesser than that. So based on this sample and these data types, we can derive that correlation. Now, the fourth question we should be asking and getting answer is, are there any missing values? So in data sets, we will be having lot of missing values, and at some time we need to fill those uh, data values uh, are replaced with some default one. But how good that data is, it will define the quality of data. If there are a lot of missing data, then it might be that sample is not good. So to get to know, we should be having is null and sum. So this is the way we should be able to get all the null against each columns. So we are seeing on for embark we got a 2, for cabin we got this much, and for age 177 member were not disclosing their age, right? So this is how we understand how much missing values do we have. And next question we should be asking, how does data looks mathematically? And so we looked around data, we understand null values, symbols, data types, how big size and all that. But in a nutshell, how mathematically we can describe that data. So to get that, df.describe will describe that. But what those are. For example, we will be getting once we'll describe that, and those data sets will get count, means uh, count of all uh, the values, right? In the sense, uh, total count of passenger ID is 891. So if you'll go to that shape, you will see the total rows are 891. So this uh, passenger ID count is 891 exactly. Means there is no null values or empty. Similarly, it will show for survived, and for P class A's we are having, right, we saw here, In A's, 177 are not there. So similarly, it will show the counts of values, right? And then it will, and basically this describes mathematically applies for numerical data types only. And that's where you will see only numerical data types are included in this analysis. So here mean of all these numericals data values, it has given here, right? Similarly, standard deviation, it has been given min and max. And this is 25 percentile. So 25 percentile um, in case of A's is this much, means 25% people are less than 20.1 year of age. And 50 percentile means it says that 50% of people are under 28 years of age. And 75 percentile means, and 75 percentile value is 38, means 75% of people were under 38 year of age. So this is how this percentile describes us. Let's talk about are there duplicate values? So in the data sets, you will often get a lot of duplicate nulls, right? So how to get the duplicate one? If you'll run that df.duplicates, you will get the duplicates and its sum. If you sum them, it will give you the number. So in our data set is pretty small, so you will not see any duplicate. Seventh question, how does correlation between uh, the columns? So how is the correlation between the columns? Means we are having columns, right? But how these columns correlates among each other? And this is normally also applies to numerical data set only. That's where here in my data sets, I have applied this filter, uh, include only numerical, and give the correlation against survived column. So this correlation will range from -1 to 1. So -1, it indicates which are the values or negative sides. It's indicate that that is contra that particular column is having contra relationship against this survived. And positive means that column is having positive side of correlation against the survived. Means if that column's value increases, the survive chances will also increase. So in this one, we are seeing that passenger ID is very less having correlation. Obviously, it, passenger IDs doesn't have any impact on survived or not. Right? Survived against survived, it's a 100%. Yep. And P class has a negative correlation. S has, and here you will see this, the fear has very positive correlation. Means if fear increases, the survival chances also increases. Means who's ever paid high, they got survived early. Our survival chances were more. Or they were getting help to get survived. So this is all the 7 questions you should be asking on the data set, given data set, and you should be able to do the evaluation or exploration. And this is the starting of EDA. So this is called exploratory data analysis as well. And in that, in further exploratory data analysis, you will be doing uh, in more detail. So in this, uh, we are again we are going to take the same uh, uh, Titanic data sets, and this is the sample. And we currently we were having survived numerical, right? But we can have a categorical data as well. So how to visualize those categorical data, right? So for categorical data, for example, sex or uh, here we are this column. So so we will be uh, doing a count plot. Uh, so one was the numerical way of describing, right? And in the next, we are going to understand how we can do the exploratory analysis in a visual way. Correct. So we will be doing some uh, graphical representation of data, and we will be looking around and doing the analysis. So that's where one option is for categorical data. You can use count plot. For example, we are having survived, right? And value counts. So total survived, and we are uh, yeah, and we are doing the bar plot. So based on the survive count, value counts, and we are plotting. So in the survived, we are having two type of value count, mostly 0 and 1, right? Either it uh, survived or not. So this is two categories. So in this, we are drawing this bar chart, and we are saying that this much were not survived, and this one where are one, we were having this 350 around folks who were survived, and 550 around were not survived in this data set, right? And another one is we can draw the SNS count plot as well. So here in SNS count plot for based on the embark, right? So how many embarked uh, based on the embarked we are going to get count. So from Shivag, no, from Southampton, this is the count near about 650. From uh, Shivag, we were getting near about 200, and from Queenstown, we got near about 90. So these were passenger counts, right? Yeah. And another representation is pie chart. This is another good way to visualize overall uh, ratio. Uh, so here uh, we are going to have group and categorization based on the sex, and we are plotting pie chart. And here we are showing that okay, we were having 64.76% of male and 35.24 ratio are female, right? And if for numerical data, we can do exploratory analysis, for example, having a histogram. So we are uh, so for numerical uh, columns, first we can draw the histogram. So histogram will show the distribution of data. So how well my data set is overall data set is distributed. So for that one matplotlib, we have to import it, and then we are going to plot histogram on age and bins of 5. So bin size is 5. We are keeping. So in the five uh, five of bins, we are seeing that data has some skewness. You will see data is not equally distributed, and uh, right. So it seems like mean falls around this one, uh, 25, and there are few data, this last one, which are too far from uh, mid median mid, right? So this data has a skewness. We can and this one would be the outlier as well. So with this, we can understand the data distribution, right? So 80, yeah. So there were few people, it seems like up to 80 years as well, right? And yeah, and this is the same drawing. And another drawing we can do or visualization is uh, this plot. So in the same way, we can get it. Uh, it's a line display on top of those data. So this is a disk plot, and then we can do the box plot. So how much data lies uh, between these? So this one is very good use case, and it is getting uh, quite often used uh, just to detect outliers and all that. So here you will be seeing in this range there are uh, data, and there are few data which are out of range. So this is also very helpful. And another thing is, if you would like to get min, you will be able to get min max, right? And mean on age, skewness in the data, you should be able to get as well. So these are the two way of doing exploratory analysis or understanding your data uh, in a non-graphical way and uh, in the graphical way, uh, you should be able to do the exploratory analysis of your data, and it will give you the understanding about the data. So hopefully this will be helpful for you, and we will see you in the next session.